So welcome again. Today we are going to discuss another experiment of this subject, physics. The aim of the experiment is to verify the inverse square law of radiations using a photoelectric cell. So here we are using this photoelectric cell, and this is our complete apparatus where we have the ammeter, milliammeter, and the millivoltmeter, one photo cell that is mounted in a metal box with the connections bought out at terminals, lamp holder with some 60-watt bulb. Okay, so these are some arrangement that we have to complete this experiment. So first we must remember what is the photocell. As a photocell is a device in which the light energy is used to create a potential difference. So optical photons are incidenting on the cell, and they will be creating a potential difference, so which is directly proportional to the frequency and intensity of the incident light. Okay, so here what we are going to verify, inverse square law. So the inverse square law is a principle that expresses the way radiant energy propagates through space. So the rule states that the power intensity per unit area of a point source, if the rays strike the surface at a right angle, so varies inversely according to the square of the distance from the source. So that we are going to verify. So here is the manual that we are using in this, and this is the tabular column. These are simply the tabular column and the principle which is involved in this experiment. Let me explain this experiment, how we will perform this. So first of all, we will switch on our bulb. So initially I am just trying to keep this bulb on, and it should be, I have just kept this at a distance, initial distance it was the 14 centimeter I am just taking, and so this distance is now I am just trying to measure this from this mark I have made, and it is now 14 centimeter, and you can see the distance between the photocell and the source bulb. Okay, so from this point we have marked, as this is the distance of the box only, and bulb is up to this part only. Okay, so this is the 14 centimeter, and what exactly the value that we can have in our apparatus, so that we can observe by this ammeter and the voltmeter. Okay, so that we will note down. I am just trying to note these values on the tabular column. Then what we will do, we will change the distance, and it is now 16, and then again we will observe the values. Okay, we will note down, and similarly we will change by 2 centimeter again. It's 18 centimeter distance now. Okay, so let me note and write these values. So these are the values that we have observed by this experiment. I think it is visible now. All the observation data that we have recorded from this experiment, the value of the D that we vary from 12, this distance between the photocell and this source. So this is 12, 14, 16 and 18 that we have considered, and correspondingly what is the observed values from voltmeter and the ammeter V and I that we noted down. Make the calculation for this, and if we will plot a graph between this P versus 1 by D square. Okay, so it may be as if you will plot the graph. So I have just drawn here the model graph. Okay, this is the model graph which is here you can see. So like this your graph will be there. Okay, and then if you may write the result that your inverse square law is verified if it is in a straight line like this. Okay, this is what P versus 1 by D square. Okay, so these are the observation data and recorded values that we did here today by this experimental setup. Okay, so like this your experiment is completed for this inverse square law. So thank you for watching.